All right, Algebra 2, we are in Chapter 5, Section 3. A little review, let's graph y equals 2 over x. If you remember, that is a hyperbole where I have an horizontal asymptote and a vertical asymptote at those two spaces, or those two lines. Goodness, I can't talk. So there's my asymptote and there's my asymptote. I'm not going to graph it really accurately, but I know that my graph looks like this and that. Find the vertical and horizontal asymptotes of this problem. I get my vertical asymptote at x equals 1, which comes from the denominator, and my horizontal asymptote of y equals a over c, or 4, which that's a over c. All right, let's learn a new key concept. Graphs of rational functions. So here we have that p over q thing again. If you remember a rational function, the definition we've got is p over q, where q cannot be 0. And it's a polynomial over a polynomial. So here we have p and q, and they're polynomials with no common factors other than the constant at the end. Okay, the constant at the end. There's nothing common about them. If you remember what a factor is, if I have something like x squared minus 4 equals 0, and I tell you to factor it, you've got x plus 2, and x minus 2 equals 0. So the factors of that polynomial are -2 and 2. Okay, so here we have, let p of x and q of x be polynomials with no common factors other than plus or minus 1. The graph of the following rational function has the characteristics listed below. So we have f of x equals p of x over q of x. This is just a polynomial. A x to the m, a smaller x, so if this were squared, this would be to the first power, etc., decreases by 1 as far as the x powers go, over b sub n, x to the n, so we have a higher power and it decreases as the powers go. These two things at the end are the constants. Let the x-intercepts of the graph of f are the real zeros of the numerator. Okay, these right here are an example of zeros. The graph of f has vertical asymptote at each of the real zeros of q, which is the denominator. Okay, so we have to treat the numerator and the denominator separately. The graph of f has at most one horizontal asymptote, which is determined by the degrees m and n of the numerator and the denominator. So I've got one asymptote that goes this way, and it's determined by the degrees, which is the power of m and n of the numerator and the denominator. It's a lot of information, I know. Okay, so this is what we also have to remember. When the degree of the numerator is smaller than the degree of the denominator, the line y equals 0 is the horizontal asymptote. When the degree of the numerator is equal to the degree of the denominator, the line y equals a over b is a horizontal asymptote. And if, this is a over b, let me change colors. Okay, a over b is the horizontal asymptote. If m as the numerator is bigger than n as the denominator, the graph has no horizontal asymptote. The graph's end behavior is the same as the graph of this. Okay, the end behavior is what the graph does at the end of the curve. So if we have any curve, the end behavior is what the graph does at the end. Like these go infinitely in a positive direction. All right, let's do one. Hopefully it'll make sense. All right, so we have graph y equals 6 over x squared plus 1, state the domain and range. The numerator is 6. It has no zeros. It doesn't cross an axis at any spot. Okay, so there is no x-intercept. right? The denominator has no real zeros. That means if we did x squared plus 1 equals 0, try to solve for x, square to both sides, okay, not real. So there is no vertical asymptote either. So we know the numerator has no zero, so there's no x-intercept. The denominator has no real zero, so there's no vertical asymptote. The degree of the numerator is 0. The degree of the denominator is 2. So we have, if we look at the last slide, m is less than n. That's from our last slide. You can check it out. M is less than n. The degree of the numerator is less than the degree of the denominator. So the line y equals 0, horizontal asymptote, is y equals 0. Okay, that's our horizontal asymptote. So if we look, horizontal asymptote is y equals 0. That's right here, right? All right, so I'm going to plot a few points. Everything's going to be positive y's, but I need another sheet of, well, paper-ish stuff to write on. All right. Oh, I don't want red. X-axis, y-axis. We know that the x-axis is the horizontal asymptote because that is where y equals 0. I'm going to plot a few points. Let's just do a few negatives. I always like doing 0 if I'm allowed to, which here I'm allowed to. If I plug this into y equals 6 over x squared plus 1, let's see, negative 3 squared is 9 plus 1 is 10, so 6/10, or 0.6. If I plug in negative 1, I get negative 1 squared is 1 plus 1, so that's a 3. If I plug in 0, I get 6. If I plug in 1, I get 3, and 3, I get 6/10, or 0.6. All right, so 1, 2, 3, 0.6. If I go negative 1, I go up 1, 2, 3. 1, 2, 3, and 0 is 6, which I need more space. 4, 5, 6. There we go. It's a pretty funny looking curve. So here we know the domain, which is the x values, are all real numbers, and the range is going to be, I can't cross 0, and I can't go above 6. So that is my range, and actually that is wrong. I can't be equal to 0. Okay, these are, I'm sorry, my dog's in the background. These are a tad bit harder, but with practice we'll get it, right? Right, a little bit different. We've got more going on in the numerator. So first we'll look at the 0 of the numerator. We have 2x squared equals 0. Solve that for x. X equals 0. So this right here is my x-intercept. Denominator. X squared minus 9 equals 0. X equals plus or minus 3 when I solve that. So these right here are both of my vertical asymptotes, 2 of them. Wow, I really don't know how to spell that word. I think I spelled it wrong in the last video. Vertical asymptotes. Okay, both x equals +3 and -3. So here I have, let's get the highlighter out. X equals -3, x equals +3, and an x-intercept of 0 right there. So I've got this one and both of these graphed. Let's talk about our vertical asymptote. So the numerator has a degree of 2. The denominator has a degree of 2. Since m equals n, I have a horizontal asymptote of y equals a over b, which is 2 over 1, which is 2, which we will see right here. Okay, my horizontal asymptote. Got it. Yep. So these are sort of difficult, right? Now we need to plot some points in between all of that garbly-gook. Let's pick some. Pick some points to plot. I need some points, let me see, over here. So this is 1, 2, 3, 4, 5, 6. So let's start out there, 5 and 4. I need some points in between. So we'll do 1, 2, 0, 1, 2. Sorry, this is -5 and -4. Do a -2, a 0, and a 2. And then we'll do a +4 and a +5. Okay, that's a lot going on. All right, plug that into 2x squared over x squared minus 9. I've already calculated a few of them because that's a lot of button pushing. Okay, -1.6, 0. We knew that one though. Okay, that was our x-intercept up there. If I plug in a 2, I get -1.6, 4.6, and 3.1. If we go ahead and plot these, -5 up there, -4, a little bit bigger, -2, 0, +2, and then we're up here. That's how we know our curve's shape. Okay, we're not getting everything exact, but we definitely know the asymptotes and the general curve's shape. Cool? All right, now we have where m is greater than n. We aren't doing many more than these, but we do need our numerator to find what the zeros are. X squared plus 3x minus 4. Let's go ahead and factor this. I have x plus 4, x minus 1. X equals -4 and x equals 1. These are the two zeros, so these are our x-intercepts, which we see right here. X equals 1, x equals -4. All right, keep on going. I've got the denominator has a 0 of x equals 2. So this is the vertical asymptote. Which we've put right here. That's x equals 2, my only vertical asymptote, right? Okay, this is by far the harder one. All right, the degree of the numerator is 2. The degree of the denominator is 1, so m is greater than n. So the graph has no horizontal asymptote. And the graph, this is where it gets hard in my mind, the graph has the same end behavior. Oh, as y equals x to the m minus n, or just x. So y equals x. So that's just the end behavior. Okay, and that's a line. I mean, if I look at just a random coordinate coordinate plane, the graph y equals x is just like that. So if you look, that's this end behavior right here. Pretty cool, right? So we don't know the curve yet, but we do know the vertical asymptote. So let me get a new sheet. So this is my xy axis. I have a vertical asymptote at x equals 2. I'm going to graph some points to the left and to the right. Of that vertical asymptote. So, gosh, 0, -2, let's just do -4, -2, 0, and then +2 is the asymptote, so +4, +6, and see what happens. If I look at my graph, if I look at my equation, let me calculate these, I'll be right back. Okay, we know this is actually a 0, and 0, 2, if I plug in 4, let me get the rest of them, be right back. This one right here is 1.5. If I try the same thing with 6, be right back. This one is 12.5. Doesn't go very far, does it? All right, so -4 is 0, -2, +1.5, 0, 2, I think I need to test out 1. Put 1 right there. Let me see the equation again. If I plug in 1, I get 1 plus 3 minus 4, which is 0. That's a 0. We knew that. All right, so my end behavior is sort of linear there. Then it goes down. If I plug in the rest of them, I'm at 4, which is 12. Way up there, 6, which is 12.5, hardly down. If I do 8, plug that in, I get 14, and then 12, 17.6. So we're actually coming back up. So there we go. And this is linear that way. Okay, I told you these were sort of hard, but you guys are doing great. Okay, we don't have much further to go today. Okay, we're just going to practice to graph the function. All right, I'm going to write down the stuff that we know. Okay, this is all the stuff that we've learned. The numerator has no zeros, therefore there's no x-intercept. The denominator has no real zeros, therefore there's no vertical asymptote. M is less than n, therefore y equals 0 is the horizontal asymptote. So I've got this as a horizontal asymptote. I have no vertical asymptote. I'm going to see where my graph peaks, okay, by plugging in x equals 0. So I get 4 over 0 squared plus 2, which is 2. That's how we know that point is right there, and then I can graph it down on both sides. Okay, let's try another one. All right, give me a sec. I'm going to write some stuff down that we know. All right, here's what we know. Numerator, my 0 is x equals 0. Therefore, that's my x-intercept, which I can plot right here. Okay, the denominator, the zeros are x equals plus or minus 1. So that is my vertical asymptote. That's a terrible line. Yeah, much better. That's a vertical asymptote and a vertical asymptote. m equals n, so the horizontal asymptote is y equals a over b, which is right here. So is y equals 3, right there. Now we can plot a few points, or we actually have the general shape of our curve, right? I know these are up here, and this one goes in between with the x-intercept at 0. These should all have arrows on them. Okay, graph the function. Be right back. Okay, this is an interesting one. We got the numerator. The zeros are y equals plus or minus the square root of 5 just by solving this. Therefore, those are the x-intercepts. Okay, right there and right here. Denominator, there are no real zeros, therefore there's no vertical asymptote. Here we have m equals n again, so the horizontal asymptote is a over b, which is right there, which is y equals 1. It's right here. So I know this is all below that horizontal asymptote, but I don't know how low it goes. So if I plug in x equals 0 to the equation, I get 0 squared minus 5 over 0 squared plus 1, which is negative 5. So I know this right here is negative 5. 1, 2, 3, 4, 5. Yep. And then I can curve it up through the x-intercepts. And it works quite well. Cool. Last one. Okay, I'm going to solve the numerator and the denominator. Okay, here we have my numerator solves. I solved the numerator and got the zeros or the x-intercepts of, I see a mistake, x equals 3 and x equals negative 1. That didn't come out very well. The denominator solves for x equals 4, so that is our vertical asymptote. So we have our intercepts of positive 3 and negative 1. Vertical asymptote of x equals 4. M is greater than n, therefore we have no horizontal asymptote, but my m behavior is that linear function again. Okay. Here we sort of do need to plot a few points to figure out what it looks like. If I look at the left side of the vertical asymptote, I know that I have a 0 here and there. I'm going to pick a number in between those 2 points and plug it in and solve for it. 2 is in between it. I'm just trying to find sort of the peak of that curve. So if I put it into the numerator, I get 2 squared, which is 4, minus 4, which is 0, minus 3, over 2 minus 4, 4 minus 4 minus 3. And I'm dividing by 2 minus 4, which is negative 2. That's 1.5. So we've got this curve pretty well right here. And then you need to pick a few points to plot over here. So this is 4. We can put in 5. 2, 4, 5, 6, 5, and 7. Okay, 1 second. So I plug in 5, I get 12. Oh, this was 1.5. If I plug in 7, 7 times 7 minus 14 minus 3. Minus 14 minus 3. I didn't do that right. Divide by 3. I get 10 and 2/3. So 5 would be 12. 2, 4, 6, 8, 10, 12. 7 would be 10 and 2/3. 2, 4, 6, 8, 10 and 2/3. And that, I know that in behavior goes this direction, that line. Okay, these are not as easy to graph, but you can definitely get the x-intercepts, the denominators, and horizontal asymptotes. All right, and your daily homework, right? The quizzes, sorry. And the last sheet. Good job.